In the next example, that is example 7, it says from a point on a bridge across a river, the angle of depressions on the banks opposite sides of the river are found to be 30 and 45 degree. If the bridge is at a height of 3 meters from the banks, find the width of the river. So let's say if I make the river, say this is the width of the river. So this is the width of the river. Let A and B are the two banks of the river, and there is a bridge over it. So this is the bridge over it. And there is a point on the bridge. I took this point as say C is the point. And this point C, from this point, the angle of depressions are formed, and the two angle of depressions are at the point A and that of B. That is the two banks A and B. The angle of depressions are mentioned here. The bigger one, which appears to be the bigger, as you can say, this appears to be bigger. So this is 45 and this is 30 degree. And the height of this this bridge is given. So height of the bridge is always a perpendicular. So I can make this as perpendicular. So let's this be D here, and which is according to question is given as 3 meters. Now, first of all, using alternate interior angle, I can say this is 45 degree and this angle has to be 30 degree. And what we have to get is through width of the river. As you can see from the figure, width of the river is this AB, right? We have to get the length of this AB. Right, for that we can apply trigonometric ratios, and we'll be using tan. As you can clearly see, we need a relation between the perpendicular and the base. So we can apply in right angle triangle. What is that? Is ADC. First I consider a triangle ADC. The triangle mentioned here is ADC. This one I'm talking about, this triangle ADC, right? In this triangle ADC, we are going to apply tan 45. So why tan? Because we need a relation between perpendicular and base. So tan 45 degrees equal to perpendicular. Perpendicular is CD over the base, which is AD. The value of tan 45 is 1, and CD is mentioned in the question, that is 3 over AD. By cross multiplication, we got AD as 3 meters. Now let's take the other triangle here. The other right angle triangle is in right triangle BCD, right? We are talking about the triangle BCD here. That is this one, this triangle BCD. So in this triangle, we will apply trigonometric ratio, that is tan again. So that is tan 30, that is equal to perpendicular, which is CD again, and the base is BD. Tan 30 is 1 over root 3, that is CD upon BD. By cross multiplication, we can say BD is equal to root 3 CD, and CD, as we know, we can replace this CD. Let's make one more additional step, or we may simply write in the previous step only CD as 3 meters over BD. By cross multiplication, BD is equal to 3 root 3, that is 3 root 3. Now, once we get the length of these two, we can see that we have to get the length of AB, and from the figure, it is clear that AB can be obtained as AD plus BD. AB is what we have to get. AD we have calculated as 3 meters. So we can write 3 here, and BD, right? AB from here and BD from here is 3 root 3. Later on, we can take 3 common and write this as 1 plus root 3, or maybe root 3 plus 1 meter. And that will be the width of this river.